Hey, what's up guys, and welcome to this integral calculus. We're going to use the U substitution to integrate the two functions you can see here below. We have first a power function and we have a cosine function. The thing about substitution in general is that you can break a complex term down into a simple one and then plug it back into the result once you're done with everything. So we will start with this first one here by letting first u be x plus 4, right? And then we can compute the differential, the derivative of x of u. Oh, sorry, I wrote it back here. Okay, that's what I meant. We can let u be x plus 4, this term right here, okay, and then we can compute the derivative or the differential of u, and that derivating u here will give us 1 plus dx, right? Now we can go back to our integral right here and eliminate every x in there and write our integral completely in terms of u, and it goes like this. So we're gonna have our integral here. We having u equals x plus 4, so we're gonna replace it by x plus 4 right here to the power 5, and then du equals to dx, so we're gonna replace dx here by du. Okay, so that's how it looks like, and we can integrate. We just have to integrate x to the power of u to the power of 5 now. And as you can see, our integral has become easier than before. So we're going to integrate this one here, integrating u to the power of 5. Okay, so we're going to add 1 to the power. So new power will be 6, gives you 6. And then 1 will divide the new power, 1/6, and plus the constant of integration. Okay, and now, like I told you before, we can plug back the u value in our result, in our final result. Okay, so we can say finally that x plus 4 to the power of 5 dx equals to 1/6. Okay, x plus 4 to the power of 6 plus the constant of integration, and that's our result, right? So this is our first result of this integral. In this second example, we're gonna do the same thing by letting u be 3x plus 4, and we can also compute its derivative, right? And it gives us here 3 dx. Okay, and of course we can also write here, because the thing is, just like we did here, we're gonna eliminate all the x here and replace it by u. This is what we call the substitution. Okay, so we can say here that du divided by 3 equals to dx, and this value we're gonna put it here, all right, or 1/3 of du. Okay, so now let us go back to our integral now and eliminate all the x that are in there. We write the integral like this way now: the cosine of u, of course, so we're gonna have u now, du and dx equals du divided by 3. Okay, and that's what we're gonna integrate now, and we can write this integral by taking that 1/3 out of the integral sign, will be equals to the cosine of u du, right? Put a parenthesis here. Okay, to find the cosine of u, I think I'm gonna just draw a little unit circle, okay, to show you how it works. Okay, let me take this color right here and draw a little unit circle here, right? Okay, so we having this is a unit circle, not a perfect one, but it can help. So when you're on a unit circle, right, Okay, this is a y value. When you're in a unit circle, take a different color. Okay, when you go this way, I mean, like clockwise, when you go this way clockwise, you are differentiating, I mean, you are derivating. Okay, this is a derivative. When you go this way, derivative. But when you go in any clockwise, you are integrating. Any clockwise will be integrating. So there will be just like this. Okay, it's not that good, not that beautiful, but I can. So you'll be integrating by doing this. This is the integral, right? When you go that way. Okay, let me just make some room because I'm going to write the result there. Just copy this one here and can put it there. Okay. All right. And on a unit circle, the cosine is here. I mean, the cosine positive is here. The cosine negative is here. The sine positive is there. And the sine negative is right here. Okay. So it means that we are here. According to our function, we are here. The cosine of u. Okay. It means that we are here. The integral of our function will be sine. Okay. See, it's easy. So we're gonna say that the value of our integral here will give us this is gonna be equal to 1/3 of sine of u plus the constant of integration. Sorry, plus the constant of integration plus c. It's not that what I will write in there. Okay, plus the constant of integration c. And now we can plug back. Remember that we isolated 3x plus 4 before using the variable u. Okay, so we're going to plug back the u, I mean its value, back in the function right here. Okay, so we're going to say finally that the integral of cosine 3x plus 4 dx equals to 1/3 of the sine of 3x plus 4, and then plus the constant of integration, and that's our result. Okay, so okay, this is our final result. Okay, so this is guy in the next video. I mean, thank you for watching again, and in the next video we'll be using more complex terms that we will integrate. And I mean, I just wish you to tune on, to listen and watch all I'm doing. Okay, thank you for watching again. See you later, alligator, but not for a while, crocodile.